king crab armor, a living fortress. Imagine a creature armored like a knight, yet roaming the icy depths of the ocean. That's the king crab. These magnificent crustaceans are truly giants of their domain, often reaching over 4 feet across. Their name isn't just for show, they're the largest crab species on Earth by weight and size. The hard shell protecting them is incredibly thick, providing a formidable defense against predators and the harsh conditions of the deep sea. You'll find them primarily in the cold waters around Alaska, Russia, and Japan, clinging to rocky bottoms where they forage for all sorts of tasty treats, from clams and mussels to dead fish and even seaweed. It's quite a sight to witness one lumbering along the seabed, a true testament to nature's incredible engineering. That incredible armor you see covering a king crab isn't just a shield, it's actually a living part of its body, called an exoskeleton. Think of it as a suit they wear, but one that grows with them. As the crab gets bigger, this shell becomes too small to accommodate their increasing size. To solve this, they go through a process called molting, essentially shedding their old armor and growing a brand new one underneath. It's quite an undertaking. For a period after molting, the crab is incredibly vulnerable because its new exoskeleton is soft and pliable. This makes them easy targets for predators, which is why they often bury themselves to recover and allow that new shell to harden. The amazing thing is, this isn't just replacement, it's rebuilding. Minerals are absorbed from their food, incorporated into the new shell, making it even stronger than before. King crabs, like all crustaceans, have a hard shell protecting them. It's an exoskeleton made of chitin. This shell provides excellent defense, but also presents a unique challenge to their growth. As they get bigger, the shell simply can't expand. To overcome this limitation, king crabs must go through a process called molting. It's essentially shedding that entire outer layer. The crab absorbs minerals from its diet and uses them to build a new, larger exoskeleton underneath the old one. Once the new shell is complete, the old one splits open and the crab wriggles free. This leaves them incredibly vulnerable for a period. Without their protective armor, they're easy targets for predators. The incredible growth of a king crab isn't just about eating, it's also a fascinating process of construction. Before they shed their shell, a process called molting, these crabs actually begin building their next, larger exoskeleton right underneath the one they already wear. It's like having 2 shells at once. This new shell isn't made from thin air, though. They actively draw calcium and other essential minerals directly from the surrounding seawater to strengthen it. Think of it as a constant internal project, quietly preparing for that dramatic moment when the old shell splits and they emerge bigger than before. Shedding isn't a simple process for king crabs. It's actually a period of significant vulnerability. Imagine ripping off your entire shell. That's essentially what they do. During this time, their new exoskeleton is soft and pliable, offering virtually no protection against predators like sea otters or even larger crabs. They are incredibly exposed, unable to defend themselves effectively. Because of this danger, shedding king crabs often retreat into secluded crevices or bury themselves in the sediment, sometimes remaining hidden for weeks, even months, until their new shell hardens and provides adequate defense. It's a necessary step in their growth, but one fraught with risk. King crabs exhibit a truly remarkable growth pattern when it comes to molting. Most crustaceans, like shrimp and smaller crabs, molt quite often as they grow, shedding their exoskeletons multiple times each year during their juvenile stages. But king crabs are different. These giants only molt a few times throughout their incredibly long lives. In fact, adult king crabs typically molt just once every 6 to 10 years. This slow molting rate is linked to their massive size and the sheer energy required for such a significant process. It's an investment that demands considerable resources. Take a closer look at this incredible armor. It's far more complex than you might think. The exoskeleton isn't uniform. Across its body, different sections are built for distinct purposes. You see, these plates aren't just randomly arranged. They're carefully positioned to provide maximum protection and flexibility. Notice how some areas have thinner, lighter plating for ease of movement, while others, particularly around the vulnerable joints, are thick and reinforced. And speaking of joints, did you know that king crabs possess surprisingly agile movements? They achieve this thanks to specialized hinge-like connections, allowing them to scuttle sideways with impressive speed. Finally, observe those powerful claws. They're not just for show, they're essential tools for foraging, tearing open shellfish, and scraping algae from rocks, as well as providing a formidable defense against predators. When a king crab outgrows its shell, a truly remarkable thing happens. That discarded exoskeleton isn't just waste, it's an incredibly valuable resource. It's packed with nutrients and minerals, making it a feast for many creatures of the deep. You'll often see sea stars, snails, and other scavengers quickly moving in to graze on this soft, vulnerable shell. They're essentially recycling it back into the ocean environment. This process is essential because it prevents the accumulation of dead shells on the seed and returns those vital nutrients to the ecosystem, fueling life for countless organisms. The incredible strength and resilience of a king crab isn't just about its size, it's deeply rooted in the way its shell is built. Scientists are intensely studying these exoskeletons, those discarded shells, to unlock secrets about biomineralization, which is essentially how living organisms create complex mineral structures. Think of coral reefs, or even our own bones. They all involve intricate processes of building with minerals. King crab exoskeletons provide a particularly fascinating case study because they're incredibly dense and strong, composed primarily of calcium carbonate, the same material found in limestone. By analyzing the microscopic structure of these shells, how the calcium carbonate is organized at a cellular level, researchers hope to understand precisely how the crab controls this process. This understanding could then inspire entirely new materials, science innovations. Imagine creating stronger, lighter building materials, or even advanced composites mimicking nature's own designs. The king crab's shell isn't just a covering, it's an incredibly strong and complex armor built over millions of years. Think about the environments these creatures inhabit: icy, rocky seabeds where powerful currents churn and predators lurk. This heavy exoskeleton provides vital protection against crushing pressure at significant depths, as well as potential attacks from sea otters or even larger fish. Each segment is reinforced with layers of chitin, a tough polysaccharide material, making it incredibly resilient. You can actually see the growth lines etched into the shell. Those are records of its life, marking each molt and period of growth. The thickness varies across the body, thicker over vital organs and thinner in areas that require greater flexibility for movement. It's truly an astonishing example of how nature optimizes form to meet function.